Hi, my name is Michel Onwordi. I'm an Android engineer based in Berlin. I work at Mercedes-Benz IO, and I think you can see my screen. Here's my Twitter handle in case you have maybe any questions after the presentation. So what I'm going to be doing is a quick kind of whirlwind tour through Jetpack Compose. We're going to use a sample app, a very trivial one, to kind of just go through some components of Jetpack Compose. So look at composables, modifiers. We'll talk a bit about composition, recomposition, and if everything goes well, there'll be like a small section towards the end where we'll implement something really quickly. And in the process of doing that, we will touch on remember and mutable state of, and we'll also kind of look at state hoisting and describe all of it within that. And hopefully this will be enough information to get you, I don't know, excited or interested in kind of diving deeper into Compose. So this simple app that we're going to use to describe or to go through all of these components looks like this. There's basically just a list of contents, and you click on the content, or you click on the list item, and then you can see details of a contact. So without further ado, let's hop right into it. So Jetpack Compose is basically a declarative UI toolkit that Google has rolled out now and seems to be the future of Android. And what it does is it focuses primarily on a declarative approach for defining your UIs. So the focus is on describing how data is rendered into UI or transformed, so how state is transformed into a visual representation, versus the kind of imperative style that we have now, where you take data and you walk through a tree of widgets, and you call getters and setters and mutate their internal state. At the heart of Jetpack Compose are composables, and that's what you see right here. Let me run the app quickly so we just see the app again, and then we'll use that kind of to explain everything. Right, so you can see that we have a list of contacts, and for each of these contacts, there's a row with an image and text. Right, and so we'll look at starting from that point and kind of build up towards everything that takes to make up this screen that we see here on the right-hand side. So as I said, at the heart of Compose are functions. Compose focuses on functional composition instead of the regular kind of classes and inheritance through an inheritance of behavior through inheritance. And so at the heart of Compose are these composable functions. Here we have a function called contact list item. And to make a function a composable, you simply have to annotate it with the @composable annotation. As you see, we've got that here. And what this does is it lets the Compose compiler know that there's a context that needs to be created for this specific function. And that allows something called the composer to then walk through the contents of this function and convert what's in here, or take what's described in here as a function that describes UI. Sorry? Okay, I'm just going to continue in case that was a mistake. So here in this contact list item, we have a composable called row. So within Jetpack Compose, you have layout composables that are yes.
Sorry to interrupt you. Would you mind just bumping the font size a little bit on your screen? It's a little bit hard to see on our monitors here.
Okay.
Thank you very much.
Presentation mode already. All right, let me do that. Hold on. How's it now? Is this better?
Might need to go slightly larger than that.
Okay.
Probably a couple more bumps.
Okay. Let's raise that even more. Let's say 20.
No, it's still not. Yeah. Try 40 for us.
40. Okay.
Could actually change the size in that editor though. Try pinch to zoom on the text if that's possible, or just a Command plus. Yeah. Is that all right, or one bigger? Okay, that's good. All right, thank you.
That's good.
Sorry to interrupt.
Cool. Okay. Right. So as I was saying, at the heart of Compose are composables, and a composable is simply a function that you create, which is annotated with the keyword at composable. And what that does is it lets the Compose runtime, or the kind of compiler plugin that's been written for Compose, it lets it know that this is a function that intends to take some data and describe UI, probably using other composables. And so in this particular composable here called contact list item, what we intend to describe is this row that should have an image and text. And so to do that, we use one of the layout composables that's bundled with Compose called row, which is itself a composable. So it's also basically a function. You can actually go straight into the declaration. This is small again. Go straight into the declaration and see that it itself is a composable function that takes in some parameters and makes use of other composables. So this is kind of a recurring theme you'll see in Compose, that behavior and kind of UI or layout behavior is inherited just by simply composing other functions within composables. So let's go back. So within this row, we basically specify, I'll come to the modifiers in a bit, but let's look at the contents within the row. So we specify an image composable. This is what we use to have this avatar that's present with all of this configuration here. And then for text, we basically have a text composable. Very, very simple, very easy to read. And within this text composable, we're just reading the data from our contact, which we pass in as a parameter to the contact list item here. And we just read that over here, basically, and then add some styling. So one of the nice aspects of Compose is that because it's something new, the UI toolkit team has kind of had an opportunity to correct some of the API regrets. And so you'll find that composables, also because they're functions, it's very easy to discover how to configure them. They work basically based on the parameters that you pass in, just like any other function. And so you can use the normal IDE tools to see exactly what kinds of parameters you can pass in. A lot of it is pre-configured with default values to kind of make the call site easier, kind of improve the ergonomics of the API. But here you can see, for example, there are a number of things you can configure. Now, one thing you'll see in common between all of these composables is modifiers. You'll see modifiers being applied here for the image. You'll see modifiers being applied for row as well. And what a modifier is, it's an ordered set of elements that allows you to decorate a composable with new functionality or with behavior, such as, for example, a background image or accessibility information, or also to kind of plug into the layout and measure paths of that composable and configure something like constraints for the size and so on. So here for row, in order to have it actually fill the max width, we use fill max width as a modifier. And to give it the functionality to listen to click events, we use the clickable modifier, which takes in a lambda to describe the click behavior. That's what we've got here. And then we apply some padding. And one thing that's important to note with modifiers is that they are ordered, and the order in which you specify them matters. So if I had written padding above fill max width, then that would mean first the space that's available should be padded, and then fill that space and then make that clickable. And so it's very important to always keep this in mind. One thing that Compose has that makes it kind of easy to play around with your modifiers and see how it affects the composable that's going to be generated is the preview window. Let me get that running quickly. Wow, that's, yeah. And so here you have your preview window. And this kind of lets you know what the composable you're working on will look like. As you make changes, you build and refresh, and then you'll see the changes updated in the preview. Bear in mind, Compose is still working with an alpha version of Android Studio, so sometimes the preview works, sometimes it doesn't. Hopefully it works through this presentation. Let's take a closer look at the image composable. So the image composable, in order to display the images that you see here on the screen, we're calling a simple URL called Pravatar. So we're just kind of like loading the images from Pravatar there. And we're doing this using Coil, which some of you may be familiar with. It's a library kind of like Glide that you can use for making asynchronous requests for images. Compose has there's a library for Compose called Accompanist, which has some extra kind of, I guess, composables that have not yet been merged into the main Compose repo that you can use for this. And so I've put links to that in the presentation. That library provides you with something called Remember Coil Painter. So this basically is a painter. So the responsibility of a painter is to, well, paint the content. If you were not using that library, you would basically pass in a vector image here using the standard painters that are provided by Compose. But that library allows you to plug in this Remember Coil Painter and just basically pass in a request URL that should be used, a size that can be applied to size the image, and then a behavior, whether it should fade in or out. And you can also kind of customize the animations. Here, the modifiers for the image can help also kind of illustrate this ordering of elements. So what you'll see here is that I have a padding applied of 16 dips, firstly, and then I have a background of the material color primary. For this particular project, you'll notice that the primary color is purple. I didn't change that to anything, so it's kind of the default that comes with it. So what I said is first apply a padding of 16 dips, then apply a background and make sure that background is of a circular shape, then apply a padding of 2 dips. And basically these 3 statements here work to create this kind of purple border that you see around this purple circular border that you see around the image. And then I clip the image and then I apply a sizing. Now, if you remember how this works or what it would take to do some of these types of things within the view system, I think this would be kind of amazing for you to see that it's so simple, and it kind of demonstrates some of the power of modifiers and what they're able to do for composables. And modifiers you can use in your own composables that you create as well. You'll notice this contact list item is a composable I've created, and I've exposed a modifier. And this basically means anyone that's calling this contact list item is free to customize all of these aspects that Compose exposes through the modifier API. There's one thing to be aware of also about modifiers. There are modifiers that are applicable to all composables, for example, this, clickable, padding, fill max width. And then there are certain modifiers that are only applicable to certain composables. Modifiers, unlike layout params that you use to kind of configure components in the view system, modifiers are strongly typed. And so one of the ways you can easily find out which modifier is applicable for your composable is by doing something like this. So let's look at row and see what type of modifiers are applicable for. So for row itself, it just uses the regular modifier system. But for the contents of row, which is also composable, you can see that there's this row scope that's been defined. If you go into row scope, this is basically a receiver for that lambda, and this interface here defines specific modifiers, weight, for example, and align, and align by, and there are a couple of others. Won't go through all of them now, but this usage of row scope as a kind of scope marker to illustrate exactly what composables are valid within the contents of row. This is how the scoping is applied for modifiers. And so if I'm in a row context here, so like this image and text is within this row context, if I can basically use the modifier weight. Weight is available for me to use here, but if I tried to use weight for the row itself, I wouldn't get that. There'd be no opportunity to use that. It's just something to keep in mind with modifiers. Generally, it's a good idea when you're working on Compose to take a look at the composition, the composables that have been created that you're going to work with. So just basically look at their declaration, and you'll get a clearer idea of how to use them. Okay, so moving one step up, I talked about this preview, and the way in which you can have this preview available is by using the preview annotation over a composable. So generally, you should create your composable that you intend to use for your UI, and then you should create a separate composable called a preview. And this preview composable, you can give it whatever kind of name. It's a function as well. And that should just wrap your composable, and you pass in some dummy data. And then that will allow Android Studio to have this representation here on the side. And there are lots of things that you can do with the preview section. So you can use previews to test how your UI will look. So if you click on this gutter here on the side of preview, you can configure what kind of system UI can be used. You can also configure whether it's going to be in a light mode or dark mode. So you can use it to kind of have a visual representation of various forms of your UI in different states to help you see what you need to cater for while you're designing it. I think before leaving kind of this topic of composables, I'd like to say one thing to keep in mind, and this really helped me while I was getting started with Compose. Don't think of composables as the same thing as UI within the view system, because then if you do, then you have the same kind of mental restrictions, right? So we know that when you're working with UI in the view system, you're trying as much as possible to keep the hierarchy as flat as possible. Deeply nesting is bad for performance, but with composables, that's not the case. Creating composables is cheap, so you're actually encouraged to make as small composables as possible and to just combine them. So you're really looking at the thought pattern is more towards creating pieces of Lego that you can just assemble whenever you need and in various configurations to create different types of UI. What we've described here within this composable is not UI exactly. It's more like a description. When this composable is executed, what will happen is there'll be an in-memory representation of all of this, which will later be applied by something called the applier, or we can call it the composer, into UI. So it's not directly UI. And so those types of restrictions of performance and so on don't necessarily apply here. You have other kinds of things to be concerned about, more about whether it supports proper recomposition or not. Okay, so moving on, we have one layout item kind of described, but now we need to describe a list of layout items, and we need this, contact items, and we need this list to loop through a set of contacts and represent them on the screen. If you remember what it takes to do this with the regular view system, I mean, now we'd be looking at creating a recycler view in XML, would also be looking at creating an adapter, looking at view holder, and all of these components. Whereas in Compose, all you need to do is basically this. which is kind of amazing. So there's a composable that is prepackaged with Compose called lazy column, which is also like any other composable. It's basically a function. Let me make this larger. Don't know if it's too small. It's basically a function as well that also takes in a modifier, so it works like any other composable. It has one additional feature that you may not find in other composables. So it has a kind of custom DSL called this lazy list scope. And what this DSL does, it just basically defines elements that you can use to work with your list of data and emit a specific item for each. And so let me explain this clearer. So we have items function, you'll notice here, and this is a part of this lazy list scope DSL. What that does is it's a function that receives your list of data, and we're passing into our composable this list of contacts. You can specify a key, an identifier for each item. And here we're using the ID of the contact as the identifier. And then within this items block, you pass in here a lambda that basically defines the visual representation of each contact item. And to do that, what we simply do, because we want to have a list of items here and a divider, what we simply do is we call our contact list item composable that we created earlier. We pass it the contact, we pass it the event, and we call divider. And divider itself is also, it's a prepackaged composable. If you take a look at it, it's a very simple composable that makes use of a box. A box is something kind of like a frame layout, you would say a bit. So the three components that composable that Compose makes available for you to lay out components is column, row, and box, and then constraint layouts as well. And so what divider does is it basically just uses box within it and then customizes the height of box as the thickness of the line, and then customizes the color of box. And that is what ends up creating that divider. So very simple, just taking pieces together and assembling them and creating the UI that we want. Lazy column will take care of making sure that the list is performant. So making sure that only the items which are visible are actually part of the composition and are recomposed. And so with that, we basically have the contact list. And we wrap this lazy column in our own composable called contact list, which takes in the contacts and exposes a function. You'll see this quite often in Compose, where you have data coming into a composable and events going outward from a composable. And this is because Compose works very well with the unidirectional data flow kind of pattern or architecture. And in this style of development, basically state should flow downwards from the place where it's generated or mutated and flow downwards to the components that need it. And events should flow upwards from these components all the way through to the origin point where the state comes from or where state can be mutated. And so in our case, we're exposing this contact list event all the way up until we get to the place where we can interact with the navigator so that we can navigate from one top level composable to the next. And so there's our contact list. Now, when I started the app, you would have noticed that there was a loading screen firstly. And after the loading screen, we had the contacts list being displayed. So there's kind of a state update going on. I'll go into the view model to kind of explain how the data looks. And then from there, we'll look at how this happens and talk a bit about composition and recomposition. So in our view model that's associated with this, with our composable, our view model basically exposes live data. So it makes a call to an API through the repository and fetches a list of contacts and displays either a success or an error based on whether we're able to fetch contacts or not. But initially what it returns is a loading state. So I have this sealed class here called UI state to illustrate kind of the states that the UI can be in. So loading, error, and success. I'm using live data here. This doesn't mean you have to use live data. You can actually use state flow, or you can use Compose own observable type, which is called mutable state or just state. You can use any one of these, and there are extension functions that allow Compose to observe these types and work with them. You can also use RxJava. I used live data just for simplicity, because the state flow, there's some new changes to the API for how you should work with state flow, and that makes things a bit more complicated, in my opinion, so I kept it simple with this. So here we just basically call a function called getContacts, and this function returns a live data, and we have the loading state being emitted, and then success and or error if anything occurs there. So going back from here, now within our top level composable, which I've called contact list screen. So in Compose, everything is just a composable. So you don't necessarily have the concept of a screen or not. This is something that I've just written here to make it easier for me to understand and work with. So the reason I call this function a screen is because it's basically the top level composable. It represents all of this, all of the items, all of the composables that work together to create this contact list screen that we have here. So in the contact list screen, this is where I make the call to the view model, to its getContacts method. And then I use an extension function called observe as state. This is an extension function that's provided with Compose as well. And what this does, observe as state will observe live data, and it will convert that into something called mutable state, or into something called state, which is a type in Compose that's observable. So the state type in Compose is how the compiler knows that there's a state change, and how the compiler can ask a composable to re-execute itself to show an updated state. Let's jump into this function to kind of explain. So the action, or the interaction that I'm talking about here, let's cancel this, clear it from memory, and then start again just to see what I mean. So what I'm going to try and explain is how this loading and then the contacts shows up, what you see there. And that basically happens because of state updates. And so this observe as UI state converts the live data into something called state, which is then stored in this variable called UI state. And we pass that into our composable called contact list content here. Whenever a composable is observing something of type state or of type mutable state, then the compiler keeps track of that, and it keeps track of the value of that state. And we then make use of describing it within our composable. We make use of this state, and we describe what happens, what should happen based on the value of that state. So we've described here in our when statement that if the value of UI state is error, we should show an error screen, which is in our case just a box that has been set to fill the entire screen and just has a text at the center. Or if it's loading, then we show a loading indicator, which is another composable that we've written. Basically, it does the same thing. It's a box that fills the entire screen and will show a circular progress indicator in the center. And if it's success, then it calls this contact list composable, the one that we looked at earlier, and passes in the contacts, uses the modifier to ask it to fill the entire screen, and then passes an event or a lambda, a click handler into it so that the events can go upwards to the view model. Now, the first time this composable is executed, this function, the first time it's executed, the value of UI state will be loading. And at this point, none of these other composables will be executed. The compose compiler will see that the value is loading, see that the composable that should be executed are part of what's called the composition. So the in-memory representation of UI is loading indicator. And so then we'll have the loading indicator visible, and then you have the loading spinner on the screen. Then as soon as the live data from our view model updates the state with success, the compose compiler, since it's tracking UI state, and it's tracking it because it's a value of this state type here, as you can see, state type. Since it's tracking that, it knows that, okay, now a change has occurred. And because the change has occurred, I need to re-execute this contact list content composable. And the re-execution of this contact list content composable is called a recomposition. It's called recomposition because this composable is already in the composition the first pass through these composables. This composable is already in the in-memory representation, and now its state has changed. So we need to re-execute it. When we re-execute it, we'll notice, or the composer will notice that this UI state has changed. Its value is no longer loading. The value is instead success. And that therefore it'll remove loading indicator from the composition, and instead it will execute contacts list. And that's how you then have the transition from the loading state that was visible to the contact list UI that we end up seeing now. So this is an example of how recomposition occurs. Basically, if you are designing a composable that should change the representation of UI based on state, then you need to either be you need to be working with state or mutable state. And either you do this via observing through one of the extension functions, observing a live data or observing a state flow, or you do this via something called using mutable state of as a function. And we'll look at that later on when we try to implement something for this UI. So that was an explanation of this contact list content. Now for the entire screen, you'll notice we have this composable called scaffold, which I didn't explain earlier. And scaffold is a composable bundled from the material foundation of Compose. So Compose has some core components like box and row and column. And on top of these core components, you then have the material components. And there you'll find things like button and something like scaffold and app bars and bottom app bars and so on. So what scaffold does is it enforces the typical material design structure, the structure that will have a top app bar and the option to have a navigation bar and the option to have a bottom nav bar and so on. And it does this by using something called the slot pattern. Let's take a closer look at scaffold to explain this. So scaffold is itself just a regular composable as well. So it's a function, and everything that it works with is more or less passed in via parameters. So it exposes a modifier for you to customize it. But if you look at these three here, what you'll notice is it's taking in multiple composables. So the other composable functions that we saw for kind of layout, they always took one child composable, which you would then use to describe its content. But in this case, scaffold takes multiple with specific names assigned to them. And this is what's called a slot pattern. So within scaffold itself, it's structured to place these components at specific points. So the top bar is structured to be placed towards the top, and then it provides you here with the option of passing whatever type of composable you want. So this is basically how you define, this is a function type, a composable function type. And so top bar is of type composable function. You can pass in whatever type of composable you want into this slot, and it will take it and fill it towards the top. And if you want to have a bottom bar, that's the same thing that you need to do. You pass in whatever way in which you want this bottom bar to be displayed. You pass in the composable that can describe that, and that will be slotted in at the bottom. Same for snack bar, same for the action button, same for the drawer contents. And after all of that, then you can pass in the composable sort of route that you want to be displayed within the scaffold. So to fill in the body, you could think of this more as like a body section. So if we go back here to our use of scaffold, you'll see that to have this contacts top bar at the top here, we are using the top bar slot within scaffold. We pass in our composable, so it's just our lambda that contains the composable. And we're using the top app bar composable, which also comes from material. And we just specify the title. And title, so the top app bar also makes use of this slot pattern. If we go into it, you can see it takes in a title, so here I kind of have some issues with this a little bit, because I understand the flexibility that it creates, but unfortunately here you can pass in whatever composable you want to be the title, so it doesn't necessarily have to be text. I guess they've done this for more flexibility. Let's see if the API remains this way. But in our case, we've chosen to pass in text. You can pass in whatever you want. Also for the navigation icon, you can pass in whatever you want, because this also takes in a composable that does not necessarily have to be there, so it's set to null. And also for the actions that you want to take place. So in our case, we're passing in so that we can have contacts written there. We're just passing in a text composable. We could have also passed in an image composable. We could have passed in a row of text and image. So it's really flexible in what you can do there. Although within the documentation for the top app bar, they kind of ask you to generally consider some options. So if we go back in here, you'll see that for title, they recommend, or for navigation icon, for example, they recommend that you generally stick to something that is of an icon of some sort. But yeah, like I said, since it just takes in any kind of composable, you can pass in whatever you want. If you don't like this flexibility, you can of course create your own composable that internally makes use of top app bar, and you can then specify types that you want. So you can create your own functions, create your own whole design system, and create your own functions that wrap these composables and expose only the parameters that you think are important for you. That's essentially what we're doing with the composables that we've created ourselves. So this contact list content, or let's look like this contact list composable, basically wraps lazy column and limits the flexibility of lazy column by only exposing contacts and an event. So what we're saying is anyone who wants to make use of our composable to display a list of contacts should always just provide a list of contacts. We'll expose a modifier for you to customize the way it appears, and here's an event that you also need to deal with. So this is the whole kind of concept around working with Compose. The one last thing before we go into the section where we'll do some coding. The entry point for Compose within your, so kind of the bridging point from the Android components like activity or fragments into the Compose world is this set content function, which is made available. And this set content function is the starting point. It's only from this point that you can then define your composable. So here I've defined a theme. Unfortunately, we won't be able to go into that today, but all of the code that's here will be available on the slides as well, so you can take a closer look. But also there are lots of samples that have a lot more detailed information. And so I've set up a navigation kind of tree here between the list and the screen, and the contact click event has been moved up all the way to this point so that we can call the nav controller to navigate. I'm not going to go into details of navigation because there's a second talk today that's going to talk about navigation, and I kind of like wrote some hacky stuff here, so he'll probably explain in a better way. I just wanted you to see this set content. Now, set content is available from activities, it's available from fragments, and it's also available from your regular view. But to find out more, you can check, there's a whole section on interrupt in the Compose docs to see how you can use set content to interact with the say standard Android components. So a question that often comes up in Compose is whether you still need fragments or not. That really depends on your architecture and also on whether you're starting a project from scratch or not. You'll notice I'm not using any fragments here. I have my navigation set up to just move between top level composables. But if you are starting a project not from scratch, well, then you may have to find the best way to work. It really depends on, so it's kind of like a depends situation. It depends on your architecture and your structure and how fast you want to get results. Okay. Hopefully everything else that so far is understood. So what I'd like to do now quickly is kind of look at state hoisting, and we're going to do that in the form of implementing a feature. So we're going to create a favorite feature, which is basically some kind of representation here to let you click on a contact and indicate that it's your favorite contact or not. And through this, we'll discover some more things about Compose. So let's quickly do that. Now, the way that I usually like to work with Composables is to start with the preview. Let me hide this. And let's go to preview. So I like to start my Composables in the preview so that I can get a view quickly of what they look like. So let's see, we're going to create a favorite icon preview. And then after working within the preview, I then extract the composable that I want to deal with. So our composable will work in a kind of flag style, right? So it needs to know whether something is favorite or not. And based on that, then determine how it's going to represent the UI. So what will it show, a filled in icon, or will it show an icon that's not filled in? And so what we're simply going to do, we'll use a box to create this composable. And box has, as you can see, box has the alignment of its components to top. I want to align the content so that it's centered. Yeah, content alignment so that it's centered. And I'm going to make this clickable because we want some clicking behavior here. So, but first, actually, let me apply some padding. So I'll apply 8 tips of padding all around and then make this whole thing clickable. We'll define what behavior for the clicks a bit later. Let's refresh. There isn't really anything to show, but you can see that we already have a icon preview kind of here. There's nothing to show yet because we don't have anything that can, well, anything yet that can be represented yet visually. And now since we're writing in Kotlin, you can basically use all of the constructs that are available to us in Kotlin. So I have an if condition here. I'm going to create an icon. Icon type. Yes. Icon takes in an image vector. And field icon, we're going to use the thumb up icon. So if it's favorite, then it should be thumbs up, and content description is null. Generally shouldn't do that, but just for this exercise, we're going to do that. And then if it's not favorite, then it's going to be blank. Okay, let's refresh our. All right, so here we can see our icon. Yeah, I guess looks good. We have padding and so on. The preview provides an interactive mode for you to kind of test some of the functionality of your composable in isolation, which this is pretty cool when it works. So you can see here, okay, we can click, nothing's happening, and of course that's because we haven't defined the behavior. So let's quickly set the behavior, and then I'll explain a couple of things. So what we're saying is basically every time you click, then switch the value of is favorite, right? And is favorite starts off as false. So let's build and refresh real quick. Okay. And yeah, so now you see we click and it's now it's favorite, now it's not favorite, now it's favorite, now it's not favorite. And you'll notice this composable is being re-rendered. So this is also a good way to explain recomposition. So what we have here, you'll see this remember and mutable state of. Mutable state of does something similar to observe as state that we saw earlier. What it does is it will create a type of mutable state. And as I explained before, mutable state or state, this is something that is a part of Compose's state snapshot system. So it's an observable type. Whenever the Compose compiler sees this mutable state, it will keep track of whatever variable of mutable state is being read. And for whatever composable that's reading that state, whenever it changes, it will trigger a recomposition. And remember is basically, it's a function that allows local memory within a composable. It allows the composable to cache its value within the composer across recompositions. So a recomposition, to just recap that, a recomposition means re-executing this function from the top to the bottom. Now, if we re-execute this function, but we don't remember the changed value or state, then it will always be false and will never have a transition, at least well represented. So remember allows us to store that somewhere. So when the composer is recomposing this function and it comes across something that has remember, it's not going to re-execute this line. Instead, what it'll do is it'll ask itself, what's the latest value I have for this line? And I'm going to use that value going forward. So it'll use that value in the if statement. So the first time this enters the composition, it is false. The second time, due to recomposition, it is true. And instead of the filled icon, instead of the outlined icon, we have the filled icon being shown. So we have that. And once we've done this, we can now kind of extract our composable from here. So favorite icon. Let's make this public. And we have our favorite icon composable. And we should generally follow the pattern as well, where we expose a modifier so that whoever is calling our composable can interact with our composable. Well, can customize, not interact, but can customize the appearance of our composable, at least its layout, its sizing, to make it fit. We're always thinking from the case of, reuse. Okay, I'm going to stop this interactive mode because after a while it kind of sometimes stops working. All right, so we have our favorite icon. Let's quickly plug that into our list. So we're going to come here and we're going to create a spacer. This is a component that just basically takes up space. So I wanna shift the icon. When I put it into the row, I want it to be towards the right-hand corner. So that's why I'm using the spacer. And within the spacer, I'm going to use weight. This is one of the modifiers that is only applicable to row and column. We looked at that a bit earlier. And then I just basically have my favorite icon, and I have that here. If this works, we should see it in our preview. Yes, and so we see in our preview we have the icon, and that's great. We can hide the preview and we can quickly get our emulator back and run this. And when we run it, yeah, we see that we have this, we can indicate contacts as being favored or not. And that's great. And what we've created here as favorite icon, this is an example of what's called a stateful composable. And it's stateful because it manages its own state locally, right here. So this state is managed within this composable. Generally, when you're trying to create composables, you're always aiming for reuse. And so with reuse, you're trying to go towards more stateless composables, because a composable that manages its own state introduces some problems. It doesn't really flow with the unidirectional data flow approach. So what I mean by that is, if our contacts that are coming from the view model already have a favorite feature, like an attribute to let you know whether they're favorite or not, there is no way to pass that into this favorite icon. It doesn't support that because it's managing that locally. And so state hoisting is what we apply in this situation. And state hoisting is basically just exposing the state and allowing this composable to receive the state from somewhere higher up in the hierarchy, and also passing the event from this composable here, this click, higher up in the hierarchy to someone that can actually mutate the state as a result and flow in with this unidirectional data flow. In our case, we'll be aiming to get this as high as possible so that we can pass this event to the view model, since it's the origin of our contact state. Okay, so let's do that really quickly. We've got a couple minutes left, so we can still do that. And whenever you have to hoist state, what you're basically doing is just adding a parameter and adding a function as well, if your composable generates any kind of events. So here, simply on click, and we pass in the inverse of is favorite. And we're now relying on is favorite there. I'm going to do this. I'm going to set some default params. That's just because without doing this, we will break our previews, and we don't have enough time to finish implementing this and fix the previews as well. All right, so we have favorite icon operating in this way. Where are we using favorite icon? We're using it here. And at this point, we have a contact. So we can simply ask our contact, for its favorite status and pass that in. We have to use name parameters here now, otherwise it gets confused. And we're going to pass our event upwards. So on click, but we're actually going to implement it here, and we're going to forward it in a different form beyond contact list item. So let's do that, then I can explain a bit more. So on favorite, click, oops, and contact and boolean unit. On favorite, click, and here since we have the contact, we'll pass that on from here, and then we'll just pass in the boolean value. The reason why we're making this change, so favorite icon isn't aware of contacts. It has no idea that it's used within the scope of a contact. It just knows it's a favorite icon. And so we just it knows it deals with a boolean value, and it returns a click event that deals with the boolean value. But from the contact list item, we know we're dealing with contacts. So it passes that upwards, since the view model will need to know what contact it's interacted with. I'm also going to pass in a default here to avoid breaking our preview, since we don't have enough time to fix that or fix all of them. Okay, where is contact list item used? It's used here. Here we'll do the same thing. Now we're just exposing the events, because we already have we've already passed or connected it with the data that's being passed down. So we'll just do this. Don't need this. On favorite, click. Same here. Yes, one favorite click. One favorite click. And finally, at this point, we have access to the view model. So now we can pass this value onto the view model. Set, what's the function called? Yes, one set favorite click. We need our parameters. We need contact and is favorite. So for this function, we need the ID of the contact, and we need we'll pass this on, and now we'll run it. So the contacts that are being exposed kind of have some implementation already, where some of them already have a favorite state, and so you'll see that now, since we've plugged it in this unidirectional way, and we've hoisted the state up so that the view model is fully in control of the state, we now have a representation of the state of each of the contacts coming from the view model, and we can mutate that state by clicking on our favorite state icon, and all of our favorite icon, and all of this is passed to the view model, which generates a new list of contacts, passes it back, and we have just the relevant sections of the UI updated. So it really doesn't lead to much visual representation. It's more about reusability and how you should be going about creating your composables. When you look at this composable now, it can be used anywhere with anything that supports the concept of favorite. It doesn't need to be used with contacts because it just deals with a Boolean and it passes its events. And so this is what's described as a stateless composable, and generally what you're aiming for. Okay, so I think that's pretty much all we have time for. I think I've already gone above time. So I don't know if there are any questions. I would love to answer them. I also will share this slide so that it's available, because I've put in with this slide like some terms that you should kind of remember from the things that we've covered, and links to some other talks that can give you kind of like a better understanding of what's happening under the hood, so you know how the composer works in and what this @composable annotation actually does, and also a link to the repo so that you can take a closer look at the code. Thanks for listening, and I'm ready to answer your questions if there are any.
Sweet. Cheers for that, Michel. Is there any questions from the audience? I've got the mic and I can hand it around if there is any. No.
There's a question online from Kai. There's a question online from Kai, and that question is, are you using Compose in its current state in production code already?
At MBIO, we're not using it in production already. That's because we haven't made the time to get everyone kind of up to speed on it yet. So it's only me and another person that have been spending time on Compose, and on his end, he's been spending time on Swift UI and Compose as well. So we haven't done that yet, but we are gonna look into it at some point. Just playing around with it myself, it feels like in this kind of sample app and some other smaller apps, I'd say it's ready for production. And also the assurances that we have from the team, that there won't be that much change in terms of API. So depending on your needs, depending on what your app does, I think for a lot of apps, it already has everything you need to kind of satisfy the requirements. But you also have to balance this with, migration and the cost of migration, and balance that with, churning out features as well at the same time. So there's also that whole discussion.
Sweet, cheers. Is there any other questions from the audience while we're here? Cool. All right. Thanks again very much for your talk. Round of applause. I'll hold up the microphone.
Thanks for listening.